So yesterday after the quiz, we were supposed to graph some graphs and then fill out the domain and range in interval notation. Just want to talk to you real fast about interval notation. You can only use interval notation when it's an interval of numbers. When it goes from this number to that number. You can't always use interval notation. Okay? An example where we couldn't use interval notation would be if the domain was just integers or if the range was just integers. You can't really say that it goes from this number through that number because it doesn't. It like skips over. What's it skipping over? Yeah, all these decimals. It's skipping over numbers. It's just the integers. So that one you'd have to write in set notation. But if it does go from this number through that number, we can write it in interval notation. When we write interval notation, if it includes the endpoint, then we have brackets. But if it goes up to that endpoint, but it's not equal to, like when we did the open circle when we were doing piecewise, it would be a parenthesis. And infinity is not an end. It goes on forever, so it does not get the bracket, it gets the parenthesis. And then here's a bunch of examples of different ways that you would take it from set notation to write it in interval notation. And this bottom one right here has a U in it. Does anybody remember what that is called from a previous course? Oh, sorry. The U, anybody remember? Do you know what the U is? I don't know if you guys did it in Scouts yet. Yeah? Yeah, it means union, right. That's what you say, it's union, and it's just like in conjunction with, it's like this piece and that piece together. So this one here is x does not equal 6 because it goes negative infinity all the way to 6, but it doesn't equal 6. It jumps over 6, and then it goes all the way to positive infinity. That's what that says right there. So then we have a graph, example 1a, and hopefully your graph is correct. If not, you may want to fix things. And we're going to write the domain and range in interval notation, which I haven't done yet. I wrote it in set notation. We're going to write it in interval notation. So here, our domain, it goes, it's everything except for negative 5. So it's going to go all the way from negative infinity to negative 5, but it's going to jump over that. So we're going to union with negative 5 to positive infinity. And that's how you write the domain of that function. And the range is all the way down to all the way up. It goes from negative infinity to 0, union, 0 to positive infinity. That's how you write interval notation for that. Okay? And then example B was a square root. And for this one, the domain is x is greater than or equal to 4. So when we think left to right, we think interval notation. It starts at 4. It goes all the way to positive infinity, but it can't equal positive infinity. And then the range, the lowest number is 0, so it does include 0. We do a bracket. It goes all the way up to positive infinity. And then the last graph was a quadratic. The domain is all real numbers. You can write all real numbers in interval notation. It's going to go from left to right, everything, so negative infinity to positive infinity. And then the range is all the way down, and it goes all the way down to negative infinity. And it goes up to 1, but it does include 1, so we make it a bracket. And that's how you're going to write things in interval notation in today's assignment. All right? Oops. Who needs the notes from today's assignment? So a bunch of you picked them up. So we were making tables before, just plugging in points and getting out points. We were doing input and output before. But now what we're going to do is we're going to graph things using transformations. So I'm going to make tables, but I'm going to make them slightly different. And the reason why we're doing this with tables instead of just plugging stuff in is because eventually we're going to be graphing sine and cosine. Did you graph sine and cosine last year? Did you graph tangent last year? Did you graph cotangent last year? Did you graph cosecant last year? Not everybody did. I don't know if any of the CP classes did. I don't know what the honors is, but we're going to be graphing those things, and if we can learn how to do it on easier functions, when it gets to the more challenging ones, it'll be a lot easier at that point. So we're going through the table process to prepare us for harder stuff in the future. Horizontal transformations. There's two things you need to know about horizontal transformations. They are always inside of the parent function. Inside of the parent function. So if I see a parent function like square root of x plus 4, what's my parent function for square root of x plus 4? Square root of x is the parent function. Do you see how that plus 4 is inside of that square root? Another way you could think about it being inside is there's usually parentheses, but they don't always have parentheses. This one doesn't have it, but they're understood parentheses. Like here, if I'm doing the square root of x plus 4, it's understood that the x plus 4 is all underneath that square root. So it's understood. So anything that is in parentheses or inside the parent function is horizontal. If it's outside of the parent function, like plus 6, outside of that square root, that's going to be vertical. So if it's inside, it's horizontal. If it's outside, it's vertical. The other thing that you need to know, so I have that right here, I have inside function. The other thing you need to know about horizontal transformations is you always apply the opposite of the operation to the values, the x values. You do the opposite of the operation. So if I see a plus 4 happening to the x here, what would I actually do to the x? Instead of plus 4, what would I do? I would subtract 4. It's always the opposite operation. But for vertical, it's the same operation. So where I see a plus 6 here, what would I do to the y values? Plus 6. So horizontal is in parentheses and opposite operation. Vertical is outside parentheses and same operation. And then there's a bunch of examples there. Here in the chart, this explains how with symbols we would see all the different transformations. In the middle is how you would explain the transformations when I ask you to write the transformations. You're going to use words like translate or reflect in the or horizontal shrink, horizontal stretch. You can use those words. You're not going to say goes down 4 or goes left 6. You're going to actually use the word translate. Okay? So I have examples of how you say it. And then over here is what you would do to the x values if you have those transformations. And then today we're just going to do the top 3. On Monday we'll do the bottom 2. And then same thing with vertical. I have a chart. I have a mistake in the chart. I was like copying and pasting and I forgot to change these 2 to k's. I'm going to change that in your chart. That typo. It's in the vertical chart. Which should be k's. Okay, before we do any more examples, I just want to explain the reflection one. If we have a negative sign somewhere, it's going to be a reflect, not a subtraction, but like a negative multiplied. It's going to be a reflect. And it's kind of, this is where people make mistakes. They put the wrong one. Just got to think about it. Okay, everybody give me like an x-axis, an x-axis, an x-axis. All right? It doesn't shake, I'm shaking. Then put something above your x-axis, put something above it, whatever you want to put above it. Now I want you to reflect in the x-axis, so reflect over that x-axis a couple of times. When we reflect in the x-axis, are we going vertical or horizontal? So we reflect in the x-axis is actually a vertical reflection. See how people might get confused. So give me a y-axis and reflect something over that y-axis. So we're going horizontally when we reflect in the y-axis. Okay? All right. So we have translations, reflections, example A. What you're going to do is first graph the parent function. And we're just going to dash the parent function or use a different color so you can tell the difference. The parent function is quadratic, it's x squared. So I go over to 0, 0, and then it's squared. So if I go to 1, then I go up to 1. If I go to 2, I go up 4. If I go 3, I go up 9. And it's symmetrical. So negative 1 is 1, negative 2 is 4, negative 3 is 9. So if you can remember, go out 1, out 2, up 4, out 3, up 9, really fast. And then we're going to dash that. And I'm going to put the, I'm going to fill out the table also, so I can show you how to use tables. So I've got my parent function, I've got my parent function table, and then we're ready to talk about transformations. So this transformation, x squared minus 3, you ask yourself, are there any parentheses? Is the minus 3 inside of the parent function x squared? Is it inside or outside? Outside. So this is going to be vertical. So we're going to translate 3 units down. Hopefully you don't need the table for this, but I'm going to show you the table. But hopefully you don't need the table for this one. If you just go to our parent function, just take each point and move it 3 units down. So hopefully we can just do that without the table. And in your homework, you don't have to use the tables, but eventually you might want to know how. So I'm going to show you how to do it. It's an easy one. So use the table. You say, all right, if we're going down, which variable does that affect? Does that affect x or y? That's the y. So since I'm going down, I'm just going to subtract 3 from all the y values. And it's symmetrical, so once I do half of it, the rest of it comes really fast. And then I've already graphed it, but if I were going to go graph, I would use my newest y's and my newest x's. There's only one set of x's, so I would use the original x's and my newest y's to graph them. So that's how you're going to use the table. And then domain and range, we are writing in interval notation. So the domain is all real numbers. Sorry. Don't look at that. It's very touchy today. Like you guys saw, I didn't touch anything. All right. Domain is going to be all real numbers. So we're going to go from negative infinity to positive infinity. And then the range, what's the lowest point? Negative 3. Does it equal it? It does equal it. So we'll have bracket negative 3 to all the way up positive infinity. So if you are waiting to go on in the next two graphs, you could go do your parent function. Start when you're waiting for people to fill in what to touch on the board. And if you've already completed the notes, like you started early, you've already completed the notes and you've shown me, I can hand you your assignment. Because I know some of you worked ahead. All right, the next one is h plus 5 squared. So I'm going to go do my parent function. Squared. Parent function. And this one is h plus 5 quantity squared. So since we have parentheses, what kind of translation is it? Transformation, what kind? Horizontal, right? And since it's horizontal, it's always opposite of what you see. So it says plus 5. Where am I actually going to translate? Left 5 units. This would be another one where I probably would not use a table. I would just take everything and I would just move it left 5. But I will show you with the table. Since it is left 5, we're going to change our x values. We're going to subtract 5 from all our x values. And then we would plot our new x's and the original y's because we didn't change the y's. When you do your assignment, you do not have to do the tables. I'm showing them to you. So when we do harder stuff, you know what to do. Domain and range, this is all real numbers for domain. So negative infinity, positive infinity. Range goes from down to up, positive 0 to positive infinity. So we'll do the next one. So I look and it's a squared, so I'm going to go ahead and graph my parent function. Do you think I gave you all squareds on your homework tonight? We're just practicing on squareds. But you'll have different functions, just the functions we've done in class so far, but other ones besides squared. Now, I look at my equation and I've got a few things happening. I've got more than one transformation here. So, what's one of the transformations that you see? Anybody? Nicole? Okay, so the reflection. There is a negative sign and it is outside of parentheses. So what kind of reflection is going to be outside of parentheses? Vertical. And if it's a vertical reflection, it is a reflect in the what axis? X-axis. So you are going to write reflect in the x-axis. Is there anything else happening? Rachel? Translate 2 to the right. We know it's horizontal because it's inside and it's opposite. So translate 2 units right. And what else? We're also translating 1 unit up. So we got 2 translations. Now when we go to put this in the table, or if we go to graph it, do you do multiplication first, or do you do adding, subtracting first? Do you multiply first? So if you're doing this without a table, you've got to do the reflection first, and then the adding, subtracting, the sliding. But I'll do it in the table and on the graph. So I'm going to multiply first, and it is a reflection in the x-axis. That is a vertical reflection. We will multiply our y's by -1. And then we're going to add 2 to the x's and add 1 to the y's. Is that what it was? Yeah, that's what it is. And when you go to graph it, you graph the outermost x and y, the outside x's and y's. And it should be here. Okay, when you're ready to go on, flip the page over so I know I can go. Oh wait, we forgot domain and range. I'm sorry. Just kidding. Let's do our domain and range first. Domain will be all real numbers for all quadratics. So we do -infinity, +infinity, and then range would be from lower -infinity to up +1 equal to. Now if you're ready to go on, flip it over. If you're ready to go on and you're sitting there waiting, we got to do our parent question first. Okay. Now, question D has a trick to it. So you gotta be careful when you do your homework. If you have a binomial underneath the square root, or it doesn't have to be square. If you have a binomial in a horizontal transformation, you have a binomial in a horizontal transformation. And there is a number in front of the x. Like here, there's a -1 in front of the x. If there's a -1 or any number in front of the x, you have to factor it out before you can do your transformations. You have to factor it out. Okay? You could probably get the answer by just plugging in numbers at this point. But when you get to doing sine and cosine, it's going to get really confusing. So let's practice it now. You have to factor out this -1. I'm going to say factor out coefficient if there is one, and also a translation. Now, it does not go outside of the radical. It's going to still stay under the radical, so we'll have an equation that says b of x equals still square root, negative sign, parentheses, x, and then when we factor it out of the -3, it becomes +3. So we're going to factor out that negatives, and we get x + 3 in parentheses. So now what we're going to do is we're going to say, what are our transformations? So there is a negative sign. That means there's going to be a reflection. But is it a vertical or horizontal? Horizontal. It's underneath the radical still, so it's going to be horizontal, and we reflect horizontally. Which axis? The y. So we reflect in the y-axis. And then after we reflect in the y-axis, there's a +3. So if there's a +3, what do we actually do? Okay. Left, yeah, left. Translate. Left. 3 units. I forgot to put my parent function. Parent function is at 0, 0, 1, 1, 4, 2, 9, 3 for square root. And we have a reflection, a horizontal reflection, so it affects our x's. We also have a translate left, which affects our x's. What do I have to do first? I have to do multiplication first. So if you're doing a table, you're going to multiply by -1 first. And then after we multiply by -1, then we will subtract 3. Have I pulled out my graphing calculator yet to find these answers? No. So what do you think I want you to be doing when you do your homework? Did you use your graphing calculator for every single one? No, I want you to know how to do it without, because I'm not assessing you on that you know how to plug in buttons on the calculator. I'm assessing you that you understand transformations. But if you were unsure of yourself and you wanted to go to your graphing calculator and check your answer, you could plug in the equation, and you could plug in the parent function and the new function, and just make sure you did it right. That would be a good place to go check your answer. So there is a second page, but we'll do that to make you okay. All right, almost done. We're so close. Oh, we're at domain range. All right, so domain left to right goes all the way to left, -infinity, to all the way to the right is at -3, and it does equal -3. And the range is down to up, so all the way down to 0, and it does equal 0. It goes all the way up to infinity. I see lots of you haven't really tried the next one. All right, next one is the reciprocal function, and we do have the parent function on our 1-5 notes for this one. So if you've forgotten, it is there. We don't have to look for it now. Right now, I'll put it up there. There is no stretch on this, so it is a 1/. There's no stretch. We're not doing stretches today or shrinks. So our parent function, ordered pairs, we will have at 1, 1. We will have at 1, 1, -1, -1. And then along with those, we're going to have asymptotes. Remember, there's asymptotes that like goes closer and closer and closer to it, but it doesn't pass it. There's an asymptote at x equals 0, and there's an asymptote at y equals 0. So those are the numbers I'm going to use for my parent function. This is the one that has those branches. And then we're going to go and we're going to look at our equation. We're going to say, are there any transformations? Yes. Any of them horizontal? Do we have any parentheses? Put it over here so you're not distracted. Do we have any parentheses, guys? So there's none that you can see, but there are understood parentheses here. Like the x minus 4 is all together in the denominator. It's all part of the parent function 1 over x. So there is a horizontal transformation. That's going to translate where? 2 units, which way? Right. And 4 units where? So when I go to translate 2 units right, 4 units down, you could do that visually. If I'm going to use the ordered pairs, then I'm adding 2 on my x's, and I'm subtracting 4 from my y's. And when I do that, I do it to the ordered pairs and to the asymptotes. So adding 2, I'm going to have 3, 1, x equals 2. And then for the y's, I'll have -3, -5, and then y equals -4. So we will have asymptotes at x equals 2 and y equals -4. And then our graph will just be translated. We're about to go. Okay, the domain and range, this would be the kind where they skip over a number. So our domain is going to be -infinity to 2, and then union 2 to infinity. And then the range from down to up is going to skip over -4, -infinity to -4, union -4 to infinity. A lot of you have done F, but wrong. Heads up. I'm seeing them. Okay, so on F. You got to check this out every single time you have a number in front of the x value. If it's a binomial, there's an x, -x plus 1, we have to factor it out. And it can't go outside of the absolute value. So it's going to look like d of x equals negative absolute value, negative parenthesis, x, and then we factor it out, it becomes -1, absolute value plus 3. So you have to factor that out. So this means that transformation-wise, do we have any reflections? Where do we reflect? Reflect in the where do we reflect? Y-axis and x-axis. We got both of them. And then we also have translate. Which way for the horizontal? Right. 1 and up 3 units. We're going to translate right 1 and up 3 units. So when we do our ordered pairs, our parent functions just absolute value. I'm going to use -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. When we do our table, what operation should we do first? Yeah, we're going to multiply first. So we're going to multiply, and we're doing both of them, so multiply both of them by -1. And then, oh jeez, after we multiply, We're going right 1, so that'll be add 1, and up 3, so plus 3. And then you graph the outermost ordered pairs, so the ones that I put in purple, those are the ones that get graphed. So 3, 1, 2, 2, 3. And the few of you that kind of worked ahead and had to change that last one, it's because of the factoring thing. You just got to make sure that you're factoring out that number. So I'm going to pass out our worksheet. I didn't put the domain and range. Domain and range, domain is negative infinity, positive infinity. And then the range would be negative infinity all the way up to 3, and it includes it. So I'm bringing your worksheet out. You have some time to start it. Go find your favorite kind of function. Start working on that one first if you'd like, or start at the beginning if you'd like to do that. You may have to grab out your notes from, I don't remember how to do it. You may have to get out your notes from 1.5 if you've forgotten the parent function. Like I said, I didn't give you examples of all the different parent functions we've done so far. I just picked a few. I should have to kind of pick also didn't have to. They're coming still. I know I didn't.